Alright, so we're going to continue working on with Vertex form and look at a few more of the more thinking type, problem-solving type questions. So first off, it wants us to find the mapping rule that maps points from y equals x squared to y equals 6x squared minus x minus 15. Okay, so there's a lot going on here. So first off, I'm giving you an equation, and this is in standard form. Okay, so it doesn't tell us much, just tells us the direction of opening, y-intercept, things like that. What we're looking for is the mapping rule. So remember from a few lessons ago, the mapping rule is what told us whether our vertex was shifted left, right, or up, down from y equals x squared, whether it was reflected, or whether it was vertically stretched or compressed. And what that came from was vertex form. Okay, so if we want to find the mapping rule here, we have to have this in vertex form. The only problem is we have standard form. So let's think backwards and see what we actually need to do to get this in vertex form. So to put this in vertex form, we're going to need the vertex, obviously. Okay, so to find the vertex, we need both the optimal value, okay, the y value of the vertex, okay, which to find, we need to find the axis symmetry, or the x value of the vertex. Okay, so what I'm trying to do is work backwards here to see what I actually need to figure out. Okay, if I want to have the axis symmetry, well, how do I find that? Well, I need to have the zeros. And if I need to have the zeros, I need to have factored form. So working backwards from my end goal here, which is to find the mapping rule, I can then figure out everything I need to do to actually figure out to actually find this problem, right? So you got to work right backwards. First thing I need is to find factored form, because from factored form I can find my zeros, then my axis symmetry, then my optimal value, which gives me my vertex. So then I can create vertex form, and then I can create my mapping rule. Okay, so there's a lot of steps to get this one, and it can take a little while, but we can work through it. So first off, I'm giving you standard form. How do we get to factored form? Well, we factor. So let's throw this into an array. Okay, so I'm going to get 6x squared in here, minus 15. Okay, so I'm going to need two numbers that multiply to negative 15 times 6, which is negative 90, and add to negative 1. So those two numbers are going to be negative 10 and 9. So I'm going to put negative 10x and 9x in here. Okay, so when I factor this, I'm going to get 3x and 2x. So I get this for factored form. Okay, 2x plus 3 and 3x minus 5. Okay, so now that I have my factored form, let's see what comes next. So factored form helps me get the zeros. So hopefully, I mean, it was a couple units ago, but hopefully remember how to get the zeros from factored form. We take each of our factors here, set them equal to 0, and solve for x. So this means 2x plus 3 equals 0, and 3x minus 5 equals 0. Okay, so solving for x here, I get x equals negative 3 halves, and x equals 5/3. So I've got my two zeros. Okay, what comes next? Well, I found the factored form, I found the zeros. Let's find the axis symmetry now. So my axis symmetry, we'll know, is halfway between our two x-intercepts. So negative 3 halves plus 5/3 all over 2. So I'm going to let you work with the fractions on that one. And that should give me, it'll be negative 9 over 6 plus 10 over 6 if I find a common denominator, all divided by 2. So I get 1/6 divided by 2, which is 1/12. Okay, it's not a very nice looking axis symmetry. It's going to be a fraction, 1/12. But that's okay. We can work with fractions. Okay, so I found the axis symmetry. Now I need to find the optimal value. So to find the optimal value, this is the x value of the vertex. Again, going back to a few units ago, we want to find the y value that goes with an x value. We put it into a form of the equation. So you can actually put it in for x value in standard form, or you can put in the x value in factored form. I personally find the factored form easier to work with, so I'm going to sub it in there. Okay, so copy my equation here. Replace the x in the equation with 1 over 12. Oops. So So I have 2 times 1 over 12 plus 3, and 3 times 1 over 12 minus 5. Okay, simplifying with the fractions, I get 19 over 6 in here, and negative 19 over 4 in here. So I multiply those together, I get okay, so that gives me here negative 361 over 24. This is a really, really, really ugly vertex here. Okay, so this tells me now that my vertex, after all that, is going to be at 1 over 12, negative 361 over 24. Okay, so I could create vertex form here. Okay, I don't technically need to find the mapping rule, but it will help. So what I'm going to need here, that'll be my h and my k, so I'm going to have some a value, and it's going to be x minus 1 over 12, all squared, minus 361 over 24. Okay, the only thing I'm missing here is my a value, so normally you'd have to take a point, sub it in, and solve for a, but since we came from standard form, we saw last lesson that the a value from standard form is the same as the a value to vertex form. So this a value of 6 here carries on down to be my a value in vertex form. Okay, so I can, immediately without doing any work, delete my a here and replace it with the 6. Okay, so now that gives me my equation in vertex form, everything I need to find my mapping rule. So thinking in terms of transformations, since my vertex is now at 1 over 12, negative 361 over 24, this means all my x values have shifted to the right 1 over 12, so I get x plus 1 over 12 in my mapping rule. Okay, my vertical stretch is 6, so I get 6y, and it goes down by 361 over 24. So after all that work, I finally have my mapping rule. Okay, so these are the good types of problem-solving things to look at. If you're looking for help on the extended response sections or the level 4 questions that you're going to see on a test, this would be a good type of problem to look at, right? Because there's a lot of steps involved, and you have to think through what you need in order to be able to get to the answer. Okay, so these types of questions are good. Okay, let's take a look at another one here. So we have a highway overpass. We have a shape that's modeled by the equation of a parabola. We're given the dimensions of the highway going through the under overpass. It's 10 meters wide, 20 meters high in the middle at its highest point. We want to find how high the overpass is 2 meters from the edge. Okay, so again, a little bit of a problem-solving thing going on here. I'm going to make a sketch. Okay, and where you put this sketch is really entirely up to you. A common way to do it will be to put one end of the arch at 0 and have the other side end at 10. Okay. The other thing you could do is center it around the y-axis, so you have 5 and negative 5 on either side. Okay, so again, either one will work. Your equation will be slightly different, but it'll still be a perfectly valid answer. I'm going to do it this way. Again, you can do it differently if you like, but we should get something equivalent at the end. So in the end here, if I center this around the y-axis, I have negative 5 and 5 for my distances on either side. I'm told the highway is 10 meters wide, so that's what gives me negative 5 and 5, and it's 20 meters high in the middle, so my vertex is at 0, 20. Okay, what I'm looking for is the height of the overpass 2 meters from the edge. So 2 meters from the edge, well, my edges here are here at 5 and negative 5. 2 meters from the edge would be over here at 3. So I'm looking for that height. Or I could go 2 meters from the edge in here on this side and be at negative 3. Okay, so either one of these will be perfectly valid. The only thing is, your first thought is, okay, let's just sub in 3, but I don't have anything to sub 3 into, right? I need to find the equation of this parabola before I can actually do anything with it. So that's going to be our first goal. Okay, now I have options here. I have the zeros. I could create factored form. I have the vertex. I could create vertex form. Since, again, this is the unit on vertex form, let's try and do the vertex form just to get used to working with it. So remember that vertex form is y equals a bracket x minus h squared, okay, all plus k. And I have my vertex here at 0, 20. So that's going to be my h and my k. Okay, I'm going to sub that in. So I'm going to have x minus 0 all squared plus k. Sorry, not plus k, plus 20. because k is 20. I'm just going to simplify it a little bit. X minus 0 doesn't really do anything. So just to clean it up a little bit, I'm just going to rewrite this as x minus 0, which is x, so ax squared plus 20. Okay, and what's missing here is my a value. I don't have standard form here, so I can't just take my a value from there. I have to sub in a point to find a. I can use any point I haven't already used. So I've used the vertex already. I can use either of these other 2 points that I know. Probably easier to use the one that's positive. So this right here is the point 5, 0. So I'm going to sub this in for x and y. Okay, and then I should be able to solve for a. So y is 0, x is 5, so I get 0 equals 25a squared plus 20, and from here on in it's just, sorry, not 25a squared, just 25a, pardon me. It's the 5 that's squared, not the a. So 25a plus 20, and from here on it's just algebra. So I subtract 20 from both sides, divide both sides by 25, and I get negative 4 over 5 once it reduces to be my a value. Okay, so that gives me my equation. Okay, and then I'm off to the races. So remember, what I was looking for was the height 2 meters from the edge, so I can either sub in x equals 3 or x equals negative 3. Again, the positive one's going to be easier. So I'm going to sub that in here for x, and that should give you my height. So I get negative 4 over 5, 3 squared, which is 9, plus 20. Okay, and I run all that through my calculator. I should wind up with in fraction form it's going to be 64 over 5 meters. Okay, but in decimal form it's going to be 12.8 meters. Okay, so the height of the overpass 2 meters from the edge will be 64 over 5 meters, or 12.8 meters. Okay. Alright, so that was another tricky one. Let's try another one. Okay, so now giving you another underpass, and again it's forming a parabolic arch. I'm again giving you the dimensions, and I want you to figure out this time if a truck that's 5 meters wide and 7.5 meters tall can get through this underpass. It is an example from your textbook, but it's a good thing for us to work through. Now we're going to assume here the truck can drive down the middle, so I'm going to have you do is create a sketch of this. So let's again make this sketch. Again, where I put the arch doesn't matter. I could center it around the y-axis like I did last time. I could start it at 0. Maybe just for a change of pace I'll start it at 0, just so we can sort of see how it works both ways. So it's 30 meters wide. It's going to start at 0 and end at 30 meters. Okay, and it's 10.8 meters high in the center. Well, the center happens 15 meters away. Okay, that's 10.8 meters high. So that gives me my vertex. X equals 15, y equals 10.8. Okay, so what I'm looking to see here is if the truck that's 5 meters wide and 7.5 meters tall can get through this. Now, assuming it can drive down the middle, we're going to just pretend there's no oncoming traffic as it gets through here. Where it's going to run into trouble, if it drives right down the middle, it's its best chance of fitting. Now, picture this as being a rear view of a truck, not my greatest drawing out there. But where we're going to potentially run into problems is obviously at the corners of the truck here. So basically at the edges. So we need to figure out essentially how high is the underpass at the edges of the truck, so we can see if it actually will fit the 7.5 meter tall truck or not. Okay, so that's really what we're looking for here, but again, in order to do this we have to find an equation. So what I'd like you to do here is take some time, try and create the equation of the arch. Don't worry about the truck for now, just create an equation for this arch here, in whatever form you want, vertex form or factored form. I'm going to do vertex form, and then see what we can do from there. So pause it for now, get the equation of the arch, and see what we can get. Okay, so you can take a quick look at your answer here. I started with vertex form. Again, could have used factored form, but I chose to continue working with the vertex form because we've been doing that recently. Subbed in my vertex for h and k, 15 and 10.8. And then I need to sub in a point to solve for a. So I could have used either of these x-intercepts here. I chose 0, 0 because the numbers were easier. Worked through the algebra, and I got negative 10.8 over 225. That probably reduces, but I'm not too worried about it. Just leave it like that so we've got our equation. Okay, we're going to finish this up in part 2 of the lesson, so we'll see you over there.